Okay, now I want to go on just a little bit more to run off our discussion, which is that so far we've talked about operation, add, multiply, and so on. I want to bring up the issue of comparing whole numbers. Now, comparing whole numbers, you all vaguely know, right? One number is bigger than the other. I ask you to define what it means to say. What does it mean? The total numbers m and n. What does that mean? Means what? Means what? Total numbers n, does that mean what?
M is closer to 0 than n.
What?
M is closer to 0 than n.
M is closer to 0 than n. Good. Now, that's good. Can I suggest one thing? You bring in 0, and that's not entirely necessary, is it? You can phrase it in a way that does not bring in 0. Can you try that, Bonnie?
M is less than n? And is this
No, wait, I'm asking you the meaning of less than, right? So how would you say?
There is a certain number of steps beyond m.
Good. In the process of counting, n is
M is before n.
n, okay. Well, or you can say from n you count a certain number of steps and you get to n.
Right.
But I want to go back to what you said in terms of number line. You can express this in terms of number line. And so don't bring in 0, that's all. Just directly say m less than n is what? M is to the left of n, right? Yeah. You either say m is to the left of n on number line, because this is how we do the counting on the number line, correct? 1, 2, 3, 4, 5. So if you keep counting, you go from n to n. That means you keep going to the right to get to n. Right? So that means n is to the left of n. Yeah. Okay.
So you would want to avoid describing it in terms of closer to 0, because then when you expand to negative numbers, if you're closer to 0,
But I was right. No, that's why I said it was closer to 0.
Close 0, that's perfectly fine.
Yeah.
Except that, you see, when you say something, you can say it in as few words and as clearly as possible. You should try. Now, because you look at n and n, does 0 come in here? No. Right? 0 is really not relevant. But we're looking at n and n alone, and you can say it in terms of n and n. You should try. That's what I'm saying.
Right.
So I guess I'm asking, shouldn't we avoid phrasing it that way so that when we talk about negative numbers, we never refer back to.
Well, you're right, but if you were going on the on both sides of the number line, then being closer to 0 becomes ambiguous.
Well, if it's negative 9 is less than negative 5.
But negative
So
5 is
negative
closer
to
to
0.
Yeah.
That's the answer.
Okay.
Being closer to 0 is bigger.
Yeah.
See? But you see, so far as we're doing positive numbers only, there's nothing wrong with what you said.
Okay.
But well, that's the danger with that is that you might get too used to it, and then you'll believe that it's okay to say the same thing for negative number. That's entirely correct. But the more basic issue is that if I'm only talking about n and n, when no other number comes in, why do you suddenly bring in something? It's like saying I'm talking. Anyway, you understand. It's just a matter of more clarity. Okay, or counting a certain number of steps from m gets to n. They're the same. They make the same statement. All right. Now you might wonder, n less than n. Oh, sorry. done writing? Okay. Now, you might wonder, for whole numbers, n less than n is so obvious. Why do you bother explaining what it is? Did the question occur to you? No? Oh, you really feel the need to explain what n less than n means for whole number? Really? Yes? Yes, sir? Kathy? You really feel the need to explain what it means for one whole number less than another? You do?
For myself or for my students?
Well, both.
For my students, definitely. We struggle with it all year.
What? Less than for young kids?
Sure.
What do you mean? 5 less than 9, they don't understand? They don't?
That's not intuitive. Yep.
Wait a minute. Give them 5 pieces of candy.
Well, now that's
That's
concrete.
concrete.
That's not that.
It's not that. It's not the number line, it's concrete. Oh, if it's not fair, they know.
But you should tell them that's exactly the same thing.
They have a hard time remembering the symbol, which way it should point, and then confusing the language between less than and greater than, and not knowing how to write it.
Oh, that's the confusion part about the which is which, right? That is something that.
Even the concept of less and more, you're still working within primary grade.
Okay, that's.
Because then later on, when you get into writing, like less than is referring to subtraction.
Yeah, sure.
Or
Sure,
inequality.
you also, that's why you need this concept, dealing with elementary grades, yeah. Okay, so I didn't occur to me, I thought, Sami is,
Depends on who you're working with.
how many pieces of candy, obviously one more, so that's Sami, more. 9 is more.
You can say more
That's
or
actually
greater.
I should look into this. I give you 9, I said 9 is more than 5. And you say, the kiddies don't believe me. Is that what you say? Is that what you say?
They don't understand it. All of them may not understand what that means, that they would grapple with that concept.
Really?
If you said who has more candy, they could tell you. But if you say, if you use the language and it wasn't concrete.
Because you can also hear of addition is 5 more than some number. So more could mean addition or it can mean bigger than. So like the language, like if you're a language learner, that throws you way off right there.
They're wondering what they're supposed to do instead of just.
Okay, I have to look into that. But it seems to me that there's another issue creeping in, not this one. But I'll maybe I get it straightened out later. Okay. So that's good. Now, if you feel the need to explain something like this, that's good. But I thought you always just say, this is pedantry, or people want to give us a hard time. They just want to define this, why do you bother? Well, if this didn't occur to you, that's fine, that's even better, right? So I tell you why one has to give this meaning on a purely instructional level. Because if you don't get used to the idea that whatever you do, you really explain what you're doing. When it comes to fractions, what is it going to say about fraction is less than another fraction? More is not going to do it. What is more? Fraction is very big. You don't know what's what. Right? I mean, what is it going to say? This is okay, which is big. Right, so that's not. Well, this one, some wise guy is going to give me a hard time. Right, so if I do it this way. Which is big? Which is small?
Oh boy.
No, Now you realize in your textbooks, they always say, oh, you can compare fractions this and this that way. But what does it mean to say one fraction is bigger than the other? There's never an explanation to my knowledge. Am I right or wrong? No one ever tells you what it means to say one fraction is bigger than the other. And this is the starting point. You get used to it, then it becomes natural when you come to fractions. You always ask first, though. As I told you, I want to promote this habit. Whatever you do, make sure you know what you're doing. You want students to compare fractions? Okay. What does it mean? Right, so we're going to define it exactly the same way. One fraction is bigger than the other if that fraction is to the right of the other on the number line.
Mm-hmm.
Okay, straightforward. And then students can learn how to do it. So that's why we will insist, even on the level of whole numbers, we want to know the meaning. And then become natural. You see, we just want to make sure that habits automatic and natural. With that done, so that the two rules about for whole numbers is very simple. For fractions, it's a little bit more sophisticated. But for whole numbers, the two rules, in fact, I don't even know if I want to write it down. Maybe I have to. The first rule, I'm not going to write it down. Your two numbers, one has more digits than the other, and which one is bigger? Obviously, the one with more digits. Now you know why that's bigger. All right, you try it. Okay, someone should explain to me. Why is it that a whole number with more digits than the other? Let's say M and N, right? M and N. So there's more digits. Then you want to say this. Oh, by the way, you reverse that and it becomes bigger then. You know that, right? That is smaller. So if N is more digits, the claim is that N is bigger than N. I want someone to tell me why. Someone try? No better than just say.
You have to be to the right of N on the number line.
Oh, you're not going to get that done. Yes, okay.
You've recycled, or you've used the digits that many more times, 10 more times, or however many more times than you have used the digits in N. Okay, that's horribly stated.
You probably don't mean what you say.
I know.
You're trying to say something, but you can refine it.
Yes.
But think of how do we do counting? That's why I'm trying to tell you. How do we do counting? What do you need? 3 digits. After you exhausted 2 digits, you know where to go, right? Therefore, you count a 3-digit number. You first have to go through all the 2-digit numbers. Is that correct? You'll go to 4-digit numbers. When you get the 4-digit numbers, well, only what you cannot do with 3-digit numbers is not enough for you. Then you say, I must go to 4 digits. So the very nature of counting, smaller number of digits means it's before you come to bigger digits, right? That's why you have to know exactly how to count. I'm trying to impress on you the fact that yes, that's the most important thing for whole numbers. Everyone, anything you do in whole numbers, if you don't know how to count, basically you don't know what you're doing. This main thing. So place value, as we call it, is a sort of derivative. But now you don't have to talk about place value. You know exactly what each digit means, right, to us. Then you know how to teach it. Because you now know place value is a consequence of this. Oh, by the way, so when I'm done, I think in the small group discussion, you should pick. I don't know whether you took up my offer as an over lunch, talk about how you can make use of your new understanding of place value. How do you allow that to change your instruction? How would you do something different to make students understand place value a little better? Don't forget, these are kids, right? So I don't know if you thought about it, but I think the smaller group discussion, you should take that up because this is well, that's what we're here for, to do things better. So that part's okay, right? Smaller number with fewer digits is smaller than the number with more digits. Is that clear? Is that clear? Right? Anyone want to repeat? Because our process of counting is, if 2 digits suffice, leave it alone. But only when you have done all the 2 digits, go through all the 2 digits, and you still haven't gone to that number, then you add 1 more digit to keep the counting going. So smaller number of digits always means it comes before in the process of counting than the number with more digits. Now, no ambiguity, by the way. Don't give me this thing, number looks bigger. That's not the answer, right? That's a precise mathematical meaning. So once you understand that, if I give you a number like this, 6, 7, 8, 1, 5, 2, 0, 6, 7, 8, 2, 0, 1. Which is bigger? Bottom, right? Just give some explanation why. Yes?
So you told me earlier there that if everyone has the same last name, then you don't have to refer to their last name anymore.
Exactly,
You just call them their
exactly,
first name.
exactly.
So it's the 6, 7, 8 is the same last name. So all you have to compare is 15.
In other words, to compare these two, there's no point considering the first 3 digits. Right? Now, in precise terms, what it means is what? You think of this as now, of course, the listing is going to get crazy, right? When we have 2 digits, rows of 2-digit number, and then you repeat it then and you get the 3-digit number, remember? And then you want to go to 3 digits to 4 digits, you write out all the numbers after 3 digits, row after row, and then you name them. The first row is beginning with 0, add a digit, right? Add a place. Second row is 1, right? Begin with 1. Third row begins with 2, and so on, right? Yeah. So if you imagine yourself displaying all this in a row, you know that means what? These are all in the same row. No point look, you're there in the same row, why do you bother with these? Just try them out. That's what Kelly was saying. So now you're comparing these 2 numbers. Which is bigger? Could you clearly count from here to here? Because why? In the rows of 4-digit numbers, this is the second row. That's the third row. We repeat, right? We ignore those. You look at these 2 numbers, 1520, 2011. Right? Think of this as being placed in rows and rows of numbers up to 4 digits. The label 1 here means it's in the second row. This digit 2 means in the third row. So how do we count? You exhaust the second row before you come to the third row. Therefore, in the process of counting, this comes later. It comes later. That's a big one. Okay. Yeah. So hope you appreciate knowing how to count precisely.